So let's start off by looking at the inverse of the exponential functions in the graphical calculator. Now the inverse of the exponential function is called the logarithmic function. So we have the exponential function here in blue. Now I've chosen a value of a equals 2, so this is the graph of y equals 2 to the power of x. So for example, whenever the value of x is 2, it's going to be 2 to the power of 2, which is 4. Whenever it's 3, it's 2 to the power of 3, which will give us a value of 8. 2 to the power of 4 will give us a value of 16, so on and so forth. Now we're looking to find the inverse function. Now we know from the stuff that we did on looking for inverse functions that we can find the inverse function by mirroring this function y equals a to the x on the line y equals x. So that's just what I've done here. We have a mirror of this function here, so this point here would map down to this point down here, this point here will map to this point, and this point to this point, and so on and so forth. So this function here is the inverse of the function here 2 to the x. So this is the logarithmic function that we've been looking for. Now we'll change the value of a and we'll just see these functions changing. Therefore you can see the function a to the x is getting steeper and this function here is getting shallower. So I suggest you open this up and have a little look, and you can have a play with it yourself, and you can see it when it flips over as well, and it becomes a value that's less than 0. So this gives us all of the exponential functions and all of the logarithmic functions. So let's go and we'll write down what we've learned here mathematically. So we've taken a snapshot of the screen, and you can see here we have the function y equals a to the x, and we're mirroring it on y equals x, and we're getting the inverse function here. So this is the inverse function in purple, so this is the logarithmic function. So let's just quickly talk through what we finished off in the last video. We had the problem of the population doubling, and we said that we came up with this little equation here, 1.15 to the power of n is greater than or equal to 2. So let's simplify this, and we'll just make it an equal sign. So really what we're saying is we're going to have y is equals some function a to the x. So the 1.15 is the a, and you'd replace the n with an x. Okay, so we've got this logarithmic, this exponential function y equals a to the power of x. So let's take an example, a simple example. We could say y is equal to 2 to the power of 3, which is equal to a value of 8. So this function here, for example, could be 2 to the power of x. Now this other function here, which is the inverse function, we're going to write that down in its proper format. So if this is a function here, y equals a to the x, and we've got y equals 2 to the power of 3 equals 8, so that's just one particular value for this function, then we can say the inverse is 3 equals log to the base 2 of 8. So don't get worried about this. We'll put this into words so that we can understand it. What this function says is, what number do we have to raise 2 by in order to get a value of 8? So 2 has to be raised by what power to get 8? Well, 2 has to be raised to the power of 3. So it's going to be 2 times 2 is 4 times 2 is 8. So this here is the inverse function of this exponential function, and it's called the logarithmic function. So let's look at another one as an example. If we had 2 to the power of 6 equals 64, so this is our exponential function, then the inverse, which is a logarithmic function, will say what power do we have to raise 2 by in order to get 64? And the answer is 6, because it will be 2, 4, 8, 16, 32, 64, so that's 2 to the power of 6. So more generally, this function, the logarithmic function, we can say that the exponential function is y equals a to the x. So therefore we can say the inverse function is x equals log to the base a of y. So what you can do is just put the values for x, a and y from these in and check them out. But of course we don't actually want to draw out this logarithmic function as x as some function of y. We really want it y as a function of x. So we just replace the y and the x's here. Now don't get confused about that. We've seen that whenever we were working on the inverse functions. So this function here is this function here in purple. So let's go ahead and we'll look at 2 to the power of x and we'll see how this function here is an inverse of this function, again in the graphical calculator. And don't get too worried if this looks a bit confusing. The best thing to do is work through practice examples, and we're going to be doing those in the next video. So let's look again at the exponential function 2 to the power of x. So that's 2 to the power of x in blue there. So let's say x is a value of 3. So this is 3 just here. Then we're going to have 2 to the power of 3. Well, 2 to the power of 3 is going to be a value of 8. So that's a point there. We go along 3 and up 8. So now if we look at the logarithmic function, so this is log to the base 2. So we know that whenever we go along to a value of 8, that should give us a value of 3. So this is the value of 3 here. So we can see here now in this graph here, the y-axis is the exponent. So this value of 8 will actually give us a value of 3, as opposed to the exponential function where the value of 3 will give us the value of 8. So let's go back to the original question, which was, if the population of the rabbits is increasing at 15% per annum, how long does it take for the rabbit population to double? Now we worked out an equation which would be 1.15 to the power of n, so we'll put this 1.15 in here. So the function here, 1.15 to the power of n, is the blue function. And the inverse of it, which is the logarithmic function, which is log to the base of 1.15, is this purple function. So if we start off at a value of 1, we know the population is going to double whenever it gets to a value of 2. So we're interested in this function here when it gets to a value of 2. So when the x value is 2, you can see that the y value is going to be a value of 5. So that's going to take 5 years for the population to double. So now if we were to look at and say, how long would it take for the population to go up by 4 times? So we could go along 1, 2, 3, 4 times. So this fourth one along here goes up to a factor of 10. So it would take 10 years in order for the population to go up by 4. So if this is the first time you've seen the logarithmic function, it can be quite confusing. And it's best learned by working through examples. So let's go ahead and we'll do some examples.